Hi everyone, this is Dhananjay and I'm here to explain you the number system, basics of the number systems. And now, and these are the contents what I'm going to explain you. And first I would like to explain you different types of number systems, different types of number systems, uh, decimal, octal, hexadecimal number systems. I'm going to first explain and then I will explain what is the need for the number system. And then I'm going to explain you number system conversions and then sign magnitude representation, complement representation, and what are the different types of codes. At first, what is a decimal number system? Decimal number system, it will have the radix as 10 and the numbers will be from 0 to 9. Let's This is the example for the decimal number system. It will have the numbers only from 0 to 9. And the next number system is binary number system. Binary number system consists of two numbers. They are 0 and 1 and its radix will be 2. And then octal number system. Octal number system has radix as 8 and the numbers will be from 0 to 7. And these in this number system will have numbers only from 0 to 7 only. And then hexadecimal number system. Hexadecimal number system consists of numbers from 0 to 9. From 9 it will have A, B, C, D, E, and here A is nothing but 10, B is nothing but 11, C is nothing but 12, D is nothing but 13, E is nothing but 14, F is nothing but 15. And the radix of the hexadecimal number system is 16. And this is the example for hexadecimal number system. A, B, 0, 1, 8 to the base 16. This is the example for hexadecimal number system. Here comes the question, what is the need of number system and what is number system? Number system is nothing but a language of numbers. Like in English we are using alphabets in order to convey our information. Like that, in number system we are using numbers in order to represent the information. And the next question is, what is the use of this type of decimal, hexadecimal, octal, binary number systems? In our day-to-day life we are using decimal number system only, but when you give these decimal values to the processor, which is made up of transistors, it can't understand it. So we need to convert the information in terms of zeros and ones. Nothing but 0 means 0 volts, 1 means 5 volts. In that way we have to give to the processor. So what we have to do, if you enter any key from the keyboard, like if you enter Z, the Z will be encoded by the encoder, and the processor receives Z in terms of zeros and ones, and these processor process the information and gives the result to the decoder, and decoder decodes the information, and the final result will be given to the display. The display will display the value what you entered to the keyboard here. So that's the reason why we are using these different types of number systems. And now we have to convert the number system. We need to learn about number system conversions. So how? Now first I will start with converting any radix to the decimal number system. So how I have to do that process? First I have taken one example here. In this number having two parts, one is integer part and the other one is fraction part. So how I have to do the process? If I want to convert to the base 8 to the base 10, what I have to do? I have to multiply 3 with 8 power 0, and I have to multiply 2 with 8 power 1. If any other number presents here, I have to multiply that number with 8 square, and so on I have to do, and the final result should be added here. If I take the fraction part, first I have to divide 1 by 8 and then add that value to the number 2 divided with 8 square. It's not 8, it's 8 square, and so on I have to do the process. The final result should be this value. If you do the process, you are going to get this as a result. This is how we can convert any radix to the decimal number system. If it is in the place of 8, if it is 2, we have to write here like 2 power 0, 2 power 1, 2 power 2, 2 power 3. Here 1 by 2, 2 by 2, 2 by 2 square, and so on we have to do. And here is the generalized formula in order to convert any radix to the base 10. This is the generalized formula. And now if you in that p is number of digits to the left side of the pointer, n is number of digits to the right side of the pointer, d is a number of digits, and r is the number of digits of the number system. Here p is nothing but a number of digits to the left side of the point. If we take 2 3 if we take 2 3 as a integer part and 1 2 as fraction part, so here p is 2 and n is 2. As a fraction part consists of 2 digits, here n will be 2, and d is the digits of the number system, and here it is the here d means how many digits we are having, 2 3 1 2 4 digits, so here d will be 4 digits. And here r is okay, wait, and here r is not digits of the number system, it's nothing but radix of the number system. What is the radix of the number systems? We used it in the earlier problem. We use here we use 8, so radix will be 8, so r equal to 8. Okay, so like that we can get the generalized formula here. From this we can get the final value. We can do this process with this process also. And the next thing is how to convert a decimal number system to any other number system. So if you take a number which is a decimal number, if you take this number, it has integer part and fraction part. Divide integer part and fraction part, and take integer part. Integer part is here 12. As I want to convert it into the base 2, so what I have to do, I have to divide the 12 with 2. If I divide 12 with 2, I'm going to get 6, remainder as 0. Again I have to divide 6 with 2, I'm going to get 3 and remainder as 0. And I have to divide with 2 with 3 with 2, I'm going to get 1 and remainder as 0. And I have to write this information from bottom to top. If I'm taking the fractional part, how I have to do? That means if I am having fraction part as 0.7, so how I have to Right, I have to multiply it with 2. The result will be 1.4 here. So from this I have to take integer part. 1 is the integer part here, and now I have to take the fraction part, and I have to again multiply it with 2. The result will be 0.8. From this I have to get the integer part. Integer part is 0 here, and again I have to take the fractional part. For the fraction part I have to multiply it with 2. The result will be 1.6, and I have to take the integer from here. We have to repeat this process until we are going to if you are getting the repeated sequence, then we can stop the process. Like that we have to do the process for fractional part. Like this we have to do the process for integer part, and when we concatenate both the things, we are going to get the final result 1100 1001, and I have to write it from top to bottom, and here I have to write it from bottom to top. 100 1100 100 1100.100. That's it. And now if I want to convert a binary number system to the octal number system, what I have to do? That means I would like to convert the information which is present in binary to the base 8. What I have to do? If I take 8, I can write 8 as 2 power 3. So here 3 means I need to accumulate 3 bits of this information and convert it into octal. That gives the octal number system. So if I we have to group the numbers from the point. From this point we have to do start process. How? I have to group 3 bits. So I have to group these 3 bits. I have to group these 3 bits, and I have to group these 3 bits, and I have to group these 3 bits. What is the value of 0 1 1? 3. Its value will be 3. What is the value of 101? Its value will be 5. What is the value of 0 1 1 1? Its value will be 3. So like this we can convert from base 2 to base 8 number system. And the next thing is how to convert the binary number system to hexadecimal number system. If you take a binary number system here, it's not 16, it's 2, because we are taking binary number system, and from this binary system we can represent a 16 in terms of 2 power 4. Like that means we have to group 4 bits, so that 4 bits of this information, so that we can get the hexadecimal number system. Like if you are having 11011.11010, I have to group 4 bits in order to convert the binary number system to the hexadecimal number system. So here the 4 bits are these, and these are the 4 bits. Here only 1 bit is there, so I have to add 3 more zeros. Nothing will happen. The number will have the same value even if we add 3 zeros. So I have to accumulate these 4 bits. The same thing I have to do here. Same thing I have to do there. If you if you convert this in terms of hexadecimal number, it will be 13. 13 is nothing but C, and here its value is 11, and 11 in terms of hexadecimal it will be B. This value will be 1, and this value is 0. So if you convert binary, if you want to convert from binary to hexadecimal, the hexadecimal value will be 1b dot c0. Like that we have to do the process. And now if you want to convert from octal to binary number system, what we have to do? We have to do the process, a reverse process what we did earlier in order to convert a binary to octal decimal number system. We have that means we have to take the octal number system. In this octal number system, we have to take each bit, and this each bit has to be uh, write back into 3 bits in binary, like 3 bits. How we are going to write in binary? 0 1 1. So like that. 4, how many in 3 bits how we have to write in binary? 1 0 0 0. If you want to convert 5 in binary, how what's the value we're going to get? 1 0 1. Like that we can do the process in order to convert octal to binary number system. In the same way we can uh, do for hexadecimal number system. Like uh, in order to convert hexadecimal number system to the binary, what we have to do, instead of grouping and instead of converting 1 bit to 3 bits, we have to convert 1 bit into 4 bits. That's it. And let's take an example, which is which in which we have to find the radix of the this number system. We don't know the radix of this number system. We have to find the radix for this. How to find? If this is the question they have given us, this is the question, uh, how we have to uh, find the R value. What we have to do, uh, earlier we did a process for in order to convert any radix to the decimal number system. The same process we have to do here. How? We have to multiply r with 2 with r power 0 and 1 with r power 1 and 3 with r square. The same process we have to do for the denominator. The same process we have to do for 13.1. So after doing that process, we have to 3 into r power 0 is nothing but 3, 2 into r power 0 is nothing but 2, 0 into r power 0 is its value will be 0. Then you are going to get this value. If you take the LCM and cancel the r, and if sending the left side information to the right side, finally you are going to get r square minus 5r plus 2 equal to 0. When you find the roots for this, you are going to get r equal to 5 and r equal to 0. Base, that means radix never be equal to 0. Radix will definitely start with 2 bits. So r value is 5. This is how we can find the radix if they are not, if they ask us to find the radix of the number system. Okay, I will end up this here. I will continue the remaining part in the next video. Thank you.